Hi everyone, so welcome to the next class of chemical engineering thermodynamics. So this is our fourth lecture, right? So sorry, fifth lecture. The last class we have discussed about what our first law of thermodynamics, and I hope you remember this is the equation, right? Before starting, I have already told that how to calculate this work done, right? So how to calculate the value of work transferred to a closed system, वो calculation हमारे लिए बहुत important है. Why? क्योंकि उसके basis पे बहुत सारे questions हो सकता है. और मैंने ये भी बोला था आपको, there is a difference between minus PdV and PdV. ठीक है, तो जब भी हम PdV लिखते हैं माइनस PdV लिखते हैं तो साइन कन्वेंशन के प्रॉब्लम्स होते हैं. ठीक है, तो ये भी समझना इंपॉर्टेंट है. ठीक है, सो दैट्स व्हाई वी आर गोइंग टू एक्सप्लेन अबाउट वर्क टुडे. ठीक है, सो दैट इज वेरी मच इंपॉर्टेंट. सो व्हाट वी आर गोइंग टू डू टुडे इज हाउ टू कैलकुलेट द वर्क एंड व्हाई वी आर कैलकुलेटिंग दीज थिंग्स. राइट, हमारे लिए फर्स्ट लॉ क्यों इंपॉर्टेंट है, राइट? सो दीज थिंग्स वी नीड टू अंडरस्टैंड एंड यू नीड टू स्टडी. क्लियर? सो फर्स्ट ऑफ ऑल आपको याद होगा फर्स्ट क्लास में, मतलब हमारा फर्स्ट लेक्चर में मैंने बोला था व्हाट इज द इंपॉर्टेंस ऑफ रिवर्सिबल प्रोसेस. ठीक है, आपको अगर किसी को याद नहीं है, राइट, सो प्लीज गो बैक एंड चेक द फर्स्ट लेक्चर वंस अगेन, राइट, आफ्टर दिस पर्टिकुलर क्लास. मतलब हमने डिस्कस किया था व्हाट इज द स्पेशलिटी ऑफ ए रिवर्सिबल प्रोसेस, right? Why we are interested in a reversible process. ठीक है, तो मैंने आपको बोला था this is an ideal process, right? Reversible process is an imaginary process we assume, right? Why are we imagining something? Because, right, in practically the work transfer, heat transfer, the energy transfer calculations are difficult, so we need a basis. ठीक है ना, तो हमें एक बेसिस चाहिए. सो दैट बेसिस इज योर रिवर्सिबल प्रोसेस. सो फर्स्ट वी विल कैलकुलेट द वर्क बेस्ड ऑन रिवर्सिबल प्रोसेस, देन वी विल कैलकुलेट फॉर व्हाट एक्चुअल प्रोसेस. यही हमारा हर सब्जेक्ट में होता है ना. लाइक फॉर एग्जांपल वी कैन नॉट कैलकुलेट द एक्चुअल थिंग, सो वी विल कैलकुलेट बाय अज्यूमिंग सम आइडियल थिंग, right? And we will find the value of that ideal, then we will convert it into actual, right? So this is what happening, right? So first class में मैंने बोला था, आपको याद होगा, our all equation, मतलब हम जो भी equations पढ़ने वाले हैं, right, whatever equations we are going to develop, all are based on reversible process. और हम जो भी calculate करने वाले हैं that is based on reversible work. Right, when we calculate reversible work, then we will multiply with efficiency, or some cases we will divide by efficiency. Right, ये कहाँ पे मल्टीप्लाई होता है, कहाँ पे डिवाइड होता है, वो मैंने एक बार फर्स्ट क्लास में एक्सप्लेन किया था, आपको याद होगा, राइट, विद द एग्जांपल्स ऑफ दैट कार माइलेज एंड स्टडीइंग आवर्स एक्सेट्रा. ठीक है, सो कंप्रेशन के केस में कैसे होता है एफिशिएंसी, लाइक एक्सपेंशन के केस में क्या डिफरेंस होता है, वो मैंने ऑलरेडी एक्सप्लेन किया है. I will explain it once again in the upcoming classes. Now you can see here. So हमारा aim क्या है? हमारा aim is to find the irreversible work. मतलब जो actual case में जितने भी work होता है ना, like actual case work done, we need to calculate. For example, I am compressing something. Right, so for particular compression process, I am compressing something. For that particular compression process, how much energy is required? वो मुझे calculate करना है. ठीक है ना. सो बट फॉर कैलकुलेटिंग दैट वी कैन नॉट कैलकुलेट इट डायरेक्टली बिकॉज एक्चुअल प्रोसेस के लिए हमारे पास इक्वेशन ही नहीं, राइट. सो व्हाट एवर इक्वेशन वी हैव इज रिवर्सिबल प्रोसेस, और आइडियल केसेस के लिए इक्वेशन है हमारे पास, राइट. सो फॉर सॉल्विंग एंड गेटिंग दिस इरिवर्सिबल वैल्यू with the help of the equation with the help of equations we are going to develop now. मतलब हमें आगे जो भी मैं मतलब यहाँ पे derive करने वाला हूँ वो सब reversible work है, right? वो सब reversible ideal case processes है, right? So with the help of that we are going to find the value of actual, right? So some cases में multiply हो सकता है with efficiency, some cases में divide हो सकता है. ठीक है, so this is what we are going to discuss, right? So that's why we are interested in what? We are interested in reversible work. Now a reversible process का meaning तो आपको पता है सबको, right? I hope you know what is reversible process. That is, if you have a process happening, right, if you have a process happening, a process is said to be reversible. It can go back to its initial state without affecting its surroundings, right? That is, there should not be any change in the surrounding when he comes back. Then we can say what it is, a reversible process. लेकिन ऐसा कुछ प्रोसेस होता है क्या रियल लाइफ में? नो, देयर विल बी नो प्रोसेस एज कॉल्ड रिवर्सिबल प्रोसेस. क्यों? बिकॉज with whatever process there will be some changes in the surrounding. ठीक है, so there will be some changes in the surrounding, so there is no such process as reversible process, but we assume the process to be a reversible process, right, for our easiness in calculation, क्योंकि हमें calculation easy होना चाहिए, so for that purpose we will assume a process to be reversible. ठीक है, so that is the first thing you need to understand. I hope that part is clear, right? So this is our reversible process. Now this thing can happen, that is this assumption or a process can be considered as reversible only if the driving force is very small. For example, I am taking a heat transfer process, right? So you have a system, that you have a thing that is a system at 100 degrees Celsius, right? Or I am taking a small thing that is 40 degrees Celsius, surrounding is at 30 degrees Celsius. Now there is a heat transfer is happening between these two systems. Right, heat transfer is happening between these two systems, so this process is not reversible, right? This process is not reversible because the driving force is very high, right? This driving force is very high, so if they are asking you, okay, consider this process as a reversible and do the problem, वो नहीं हो सकता. Why? क्योंकि आपका driving force है ना बहुत ज़्यादा है, right? So we can never take that this process is reversible. And if you want to assume it as reversible, then only in this case we can say, okay, we can assume it, because you can see here, if the temperature is 39.99 degrees Celsius, okay, in some cases we can easily assume that heat can transfer, go in this direction. That, for example, some heat is transferred in this direction, and after that particular thing we can get some heat back here also, because the driving force is very small. लेकिन practically ऐसा होता है क्या? नहीं. Why it is not happening practically? Because you know heat will only transfer from high temperature to low temperature. But what we are saying is, right, what we are saying is, since the driving force is very small, 1 joule इधर उधर हो सकता है, like 1 joule can go there and 1 joule can come back. That is what we are assuming. That is not practically correct, that is not actually correct, but that is our assumption. Right, that is our assumption. So your assumption of a reversible process happens only if the driving force is very small. So here the driving force dt is very small, then we will assume that, okay, this is a reversible process. Considering this, we can do our calculation, right? So again, regarding the reversible process, we will explain it further. Clear? So you might have heard this term, that is quasi-static process. Right, generally we will assume a process to be quasi-static. Quasi-static meaning is the same meaning, that is, if we are saying if it is a quasi-static compression. What is the meaning of quasi-static compression? Meaning is same thing, that is, we are compressing very slowly, that is step by step, slowly, by keeping your, right, for example, you can see here, I need to compress from 1 bar to 2 bar. This is the compression I need to do. Right, but I am not immediately compressing from 1 bar to 2 bar, then it will not be a reversible process. What you are going to do is, we are going to compress by very small pressure differences, right? That is from 1 bar to 1 bar plus small dp, that is, this will be the first driving force we are applying, right? So by dividing this particular compression step into infinite number of steps, that is very small or very slow compression we are doing. Right, so then that kind of compression we can say what it is a quasi-static compression, or it is a reversible process. Right, if the process is reversible, what has the meaning? Right, if the process is reversible, we will be able to find the value of ideal work or your reversible work required for this particular compression. For compressing from 1 bar to 2 bar, what is the reversible case? If you know the ideal or reversible case, what you can do? You can find the actual value with the help of the efficiency. Clear? So this is what we are going to do, right? I hope this part is clear regarding reversible, quasi-static, etc. Again, I will be explaining this with an example when we start solving problems. Clear? Clear? Now, after this reversible process, we are introducing our work, right? Because we are interested to calculate the work transfer or work. Clear? So work. So the total work we can divide it into two terms. That is, we have closed system work, right? We have a closed system work, and we can say we can have and open system work. Right, because we are having what, two systems, closed system and open system. Both cases we are having work transfer. So first work transfer is in the case of closed system. This case the work transfer is also called, or the work in the closed system is also called what I hope you know already, that is boundary work. Right, this is called boundary work. Why are we calling it as boundary work? Because right, we can say there is a work done or there is a work transfer only right when it crosses the system boundaries, because it is a closed system. Only if a work crosses the boundary, then only we can call it as what? We can call it as a work done, right? So then only we can call it as a work in a closed system. That's why we are telling it as the boundary work. Right, so that I will explain, because we are dealing in closed system only, right? So then I will explain it, no problem. So open system work is also called flow work, right? Or flow energy or flow work. This you might have studied in your fluid mechanics. So this part I will explain when we will explain what our open system. Now our chapter is in closed system. Clear? So we are interested to find what is the boundary work in a closed system. Clear? I hope it is done. So this is the two cases we have. Now I am starting with, our chapter is still in closed system, so I will be explaining first what your boundary work, right? We are interested in what your boundary work. So our topic is boundary work. Clear? So we are interested in the boundary work. That is, if a work crosses the boundary, or if the energy crosses the boundary, then we will call it as what? Right? Our boundary work. Now, the work which accompanies with excuse me, the work which accompanies with change in volume of the fluid always happens in closed system. That is, if you have a closed system, right? For example, which closed system you want to study? I can say there is a fluid here in a piston cylinder arrangement. This is your piston cylinder arrangement, right? So this is your piston cylinder arrangement, right? This is your piston cylinder arrangement. That is, you are going to pull this particular piston, right? So you can compress this or you can expand this, no problem. So there is a fluid is there. So when we apply force in this direction, right, अगर आप इस साइड से compress किया तो, right, so what will happen? So there will be a volume change in this direction. If it is an expansion, you will have a volume change in this direction. So this work we are interested here. That is the work which is associated with the volume change. Clear? The work which is associated with the volume change of the fluid, that particular work we are calling it as what? Boundary work. Right, that particular work we are calling it as boundary work. I hope you understood. Clear? So the work which is associated with the volume change is known as what? Our boundary work. Clear? So for this we need to find an equation, right? For this we need to find an equation. So now you can see here, excuse me, 1 minute. I hope it is clear. Now you can see here in the same example I am saying we are applying a force here, right? That is, we are compressing this fluid. So the piston moves in this direction. So I am taking a distance dx is moved, right? A distance dx is moved. So you know that any small work, that dw is equal to work equation you already know, that is F into dx. Force into displacement is your work done, right? Any work done. Now what is F? Can I write F as, can I write, 1 minute, there is some problem. Excuse me. So I can write dw, that is F, I can write it as pressure into whatever area of the piston, right? So which area I am applying that force. So area of the piston I am multiplying it as A into dx. Clear? So we can say dw is equal to area into dx is what? Your volume change, whatever volume changes happened. So dw is equal to pdv. Since I have told in the last class, right? Since I have told in the last class, our work is not a path function. Is not a state function. So normally in our books, we will represent it in del w, right? Instead of d, we will be representing it as del w. To understand or to remember that, our work is always a path function, right? So you cannot write W2 minus W1, right? That is the meaning, that is the only thing. So dW or del W is equal to PdV. Now what we learn is, right, so as a chemical engineer we learn is equation in our textbooks will be minus PdV. Why that minus is applied? Because of our sign convention, right? It is not having any other significance. PdV is the correct equation, there is no problem, everything is correct. The PdV in mechanical books, this is correct. Why are we adding a minus sign? Because of our sign convention, right? Because compression is what? Because compression is work done on the system, right? Compression is work done on the system. So according to our sign convention, we have to use this minus sign. So that I will explain now, no problem, there will be no confusion. So minus PdV, del W is equal to minus PdV is the boundary work done, right? So it is the boundary work in our closed system, right? So this is the boundary work done in our work in our closed system. So आप ये लिख सकते हैं, right? So this is the equation for what? Boundary work done. Now this is a compression process, right? I hope you know this is a compression process. We have taken an example of compression process. Now I am representing compression in a PV diagram. This is my pressure, this is my volume. So if this is my compression process, so this is my state 1, this is my state 2, right? So from 1 to 2 there is a compression is happening, right? So from 1 to 2 there is a compression, that is pressure is increasing and volume is decreasing, right? So it is a process 1 to 2, it is a compression. Up to this is okay, ठीक है? So when I say my boundary work del W is equal to minus PdV, right? When I say my this is equal to PdV, how can I represent in this particular diagram, right? Right? How can I represent this del W equal to minus PdV in this diagram? It's very simple. We are considering that, right? We are considering a small point here, a small strip here. So if you see, right, any small strip here, right, so that small strip we are considering here, this small strip, that denotes what? Your dV, right? That denotes your dV, that volume change. This P, whatever P you have considered during that very small pressure, right, so that will be what? That will be your average pressure, right? That you can take it as an average pressure. So this equation denotes only a small change in the state, right? We are not representing the complete change 1 to 2. Right? We are not representing the complete change from 1 to 2. We are representing only the small change in state. Right? तो कल के क्लास में मैंने बताया था, like this 1 to 2 will include a lot of small states. That is, from 1 to 2 during compression, you are passing through n number of, you can say infinite number of states in between this. Right? When you are compressing from point 1 to 2, you are compressing very slowly because it is a reversible work calculation, right? We are doing the compression reversibly, or we are doing the compression very slowly, and we are moving through what? We are moving through small equilibrium states. We are not compressing very fast. What we are doing is we are doing the compression very slow pace, right? So if you want to find the complete work done during the entire process, how can we calculate? We have to integrate this equation. That is, we need to integrate this equation from V1 to V2 PdV. Right? Since we have used this minus sign, so I am writing this minus sign in the outside. Right? So once again, those who are having confusion, you can see here, when I write del W equal to minus PdV, it represents only one small change. Right? It represents only this strip. Okay? So this represents only this small strip. If you want to get the total process, your work done during process 1 to 2 will be integral of PdV. From where to where you are integrating? From V1 to V2. That is, this is your volume 1, this is your volume 2. Clear? So this is what we are integrating. Or we can say, if you don't want to write V1, V2, you can say like process 1 to process 2, not process. From state 1 to, from state 2, we are integrating. So when you integrate this, you will get the work done. So what is this equation? So this equation is your reversible equation for reversible closed system work. This is your equation for reversible closed system work, not open system. We are talking about closed system. So this is the equation for reversible closed system work. Right? I hope you understood. If you want, you can say reversible closed system boundary work, because this will accompany with a volume change. Right? Whenever there is a change in volume, your boundary is moving. So we can say what? Right? That is when the piston is compressing, the boundary of the system is moving into this direction. So there is a movement of the boundary. So we can say reversible closed system boundary work also. Clear? I hope you understood. Now, same thing you can see here. This thing, how can we represent it graphically? Very simple. 1 to 2, if you are integrating, find this area. So this area under this graph represent what? This area under this graph represent your PDV. Right? So the closed system, reversible closed system work, we can always get from what? Area under the curve of PV diagram. Right? So if you find the area under PV diagram, right, area under PV diagram, right, area under PV diagram will represent what? Your reversible closed system work. Clear? So your W12 is equal to minus 1 to 2 PDV. I hope up to this is okay. Clear? So जिसको भी those who are saying like sir why it is minus PdV etc. So आप यहाँ पे देख सकते हैं, right? यहाँ पे देख लो. For example, अगर मैं compression का केस ले रहा हूँ, right? First my example is compression. So tell me what will be the sign of dV, positive or negative during compression? साइन क्या होगा आप सोच लो. राइट, कंप्रेशन के टाइम पे साइन क्या होगा? और dv के जगह आप डेल्टा v ले लो. फॉर एग्जांपल dv इज व्हाट? नॉर्मली v2 माइनस v1. राइट, और डेल्टा v इज व्हाट? डेल्टा v इज v2 माइनस v1. सो विच वॉल्यूम विल बी मोर, v2 और v1 ड्यूरिंग कंप्रेशन? सोच लो. राइट, व्हेन यू आर कंप्रेसिंग समथिंग, राइट, व्हेन यू आर कंप्रेसिंग समथिंग, योर v2 विल बी लेस कंपेयर टू v1. सो योर dv विल बी व्हाट? नेगेटिव. ठीक है ना, dv नेगेटिव होगा ना आपका, बिकॉज योर v2 इज लेस देन v1 ड्यूरिंग कंप्रेशन. ठीक है. सो अगर ऐसा है तो अगर आपका dv नेगेटिव है तो नेगेटिव मल्टीप्लाइड बाय नेगेटिव, कंप्रेशन के केस में आपका वर्क क्या होगा? पॉजिटिव. कंप्रेशन के केस में आपका वर्क पॉजिटिव हो गया ना. ठीक है. सो हमारा साइन कन्वेंशन क्या है? हमारा साइन कन्वेंशन ये है, वर्क डन ऑन द सिस्टम इज पॉजिटिव फॉर अस. इफ यू हैव कंफ्यूजन आप यहाँ पे देख सकते हैं. राइट, वर्क डन और हीट विच एवर इज कमिंग इन टू द सिस्टम इज पॉजिटिव फॉर केमिकल इंजीनियर्स. ठीक है ना, कोई प्रॉब्लम नहीं. राइट, आप देख लो मैकेनिकल का साइन कन्वेंशन क्या है. दे डोंट हैव दिस माइनस पीडीवी, उनके पास तो सिर्फ पीडीवी है. ठीक है. तो कंप्रेशन के केस में तो dv नेगेटिव उनके लिए भी सही है, कोई प्रॉब्लम नहीं. सॉरी फॉर द डिस्टर्बेंस. क्लियर. सो वी वर डिस्कसिंग दिस. सो फॉर मैकेनिकल व्हाट इज द चेंज इन मैकेनिकल? dv is same, negative for them, right? dv, that is compression case also, volume change is negative for them, there is no confusion. But what is the change for them? Right, only change for them is there is no minus pdv. So what will happen? Minus into this, so work done on the system will be negative for them. That is the only change, right? So this is the thing. So once again आप यहाँ पे देख सकते हैं, compression is always what? Your compression is always work done on the system. Why I am saying compression is work done on the system? क्योंकि when we are compressing something, we are applying something, right? So we are doing some work. So on the system, so work done on the system, compression, according to chemical engineer, this value is positive. To make this value positive, we are adding a negative sign, right? So negative into negative, it will be positive. That's why work done on the system is positive. Those who are having confusion, expansion ले लो, right? So expansion क्या है आपका? You are expanding something. So a system is expanding. When it is expanding, volume changes. What will be volume change? Positive. Right, that is when something is expanding, final volume will be greater than initial volume. So what will be your dv? Your dv will be positive. Positive into negative, so what will be your value of w? W will be negative. Expansion क्या है? Expansion is work done. Expansion is work done by the system, right? Expansion is work done by the system. So to make our work done by the system negative, we are adding this negative term. So आप देख सकते हैं according to our IUPAC sign convention, work done by the system is negative. सही है ना, right? So for mechanical engineers, what will be the problem for them? उनके पास तो ये माइनस ही नहीं है, they have only PdV. So positive, positive, positive. So work done by the system, for them it will be positive. Very simple, है ना? Right? So you need to understand why are we adding this minus, right? Why are we adding this minus? Why exactly we are adding minus? Because to make our sign convention correct. According to our sign convention, first law equation should be correct. If you are having confusion, right? You यहाँ पे देख सकते हैं, you can very easy. What is your first law equation? du is equal to del q, right, plus del w. For us, del w is minus pdv, right? For them, del w is pdv. That's why for them, their equation is what? du is equal to del q minus del w, because for them it is only pdv, so they will be writing del w equal to pdv. For mechanical, chemical, दोनों same ही है, right? So there is no change in mechanical or chemical, so your final answer will be always correct, right? So I hope you understood this, right? I hope you understood the problem with sign convention, etc. यहाँ पे अभी you can see in questions you have to read which sign convention they have used. According to that you should write the equation. Clear? So this is the meaning. If you see this, delta u is equal to q plus w. This is our equation, right? This is our sign convention, right? Under this assumption that your w12 is minus pdv. Clear? I hope you understood this. That's all. Now we will see one problem in GATE. Okay, now we will see some problem in GATE, then we will explain it once again. Now we can see this question. This is a question in GATE from IIT Bombay, right? I don't remember the year, but you can check the year. It is in our GATE Academy booklet. Now I will read the question carefully, right? So the thermodynamic state of a closed system containing a pure fluid changes from, right? So there is a closed system is there. Now they are saying that state is changing from T1 P1 to T2 P2, where T and P denote the temperature and pressure respectively. Let Q denote the heat absorbed, right? It is absorbed, okay, greater than 0 if absorbed by the system, and W is the work done greater than 0 if done by the system. Now neglect the changes in kinetic and potential energy changes, right? Energies. Which one of the following is correct? So check option A. Q is path independent, W is path dependent. B, Q is path dependent and W is path independent. So which will be correct? So if you see, already हमने explain किया है, heat and work both are path dependent, right? Your heat and work both are path dependent. So option A and B are wrong, right? So I hope you understood option A and B are wrong because both your heat and work both are path dependent. So option A and B is wrong. Now we will go for what? Option C and D. We will check which one will be correct. Clear? So I will write the options given in the question here. Clear? That is already we have told option A and B is wrong, but I will write what? Your option C and D here. Clear? What is the option C and D? Option C is Q minus W is path independent. Option D is Q plus W is path independent. So what is the meaning of path independent? Path independent का meaning है state function, right? So इसका sum एक state function होना चाहिए, Q minus W या Q plus W. अभी तो मैंने लिखा है Q plus W is delta U, तो Q plus W is delta U. So delta U is what? Your internal energy. Internal energy can be write it as U2 minus U1. Why are we able to write internal energy equal to U2 minus U1? Because it is a state function. It does not depend on the path. It is a property, right? Internal energy is a property. All properties are state function. आप लिख सकते हैं U2 minus U1. Temperature T2 minus T1. Pressure P2 minus P1. You can write it. Clear? So according to ours, which will be correct? This, because Q plus W is delta U and delta U is path independent. Simple problem is solved. But what is the real problem here? Real problem is, right, real problem is in this question they have given a sign convention. What is the sign convention given? They said work done. Read the question once again. Those who have confusion, go back and read the question. Work done by the system, they have given work done by the system is positive. In the question they specifically mentioned this, work done by the system is positive. So draw the closed system, and which is the sign convention? Work done by the system, they have given positive. So this is not our sign convention, it is the opposite one, right? So can we write Q plus W? No, because it is not our sign convention. We can write delta U is equal to Q plus W only when work done by the system is negative. Clear? So we can say what? Right? We can say, okay, this is correct, but we can say delta U is equal to Q plus W only work done by the system when it is negative. Heat transfer negative, added into the system positive, work done on the system positive. Clear? So here they have given the opposite sign convention, that is, right, so they have given this is negative and this is positive, right? So when they have given the opposite sign convention, here this will become what? Q minus W. So delta U is equal to Q minus W. So option C will be correct. ठीक है? I hope you understand how we are explain this. Clear? So we can write Q plus W equal to delta U as the first law equation only when they give you work done by the system negative, because that is our sign convention. Since in the question specifically they have mentioned it is positive, you have to use what? This equation. Clear? I hope you understood. And why I have explained this so much? Because in the question they have specifically mentioned, right, अगर एक ही sign convention है तो there is no need to explain this, right? There is no need to give the sign convention in the question, because उनको भी पता है हमारा chemical engineering books पे opposite sign convention दिया हुआ है, right? So they have to give that, they have to specifically mention the sign convention, right? अगर ये एक mechanical engineering question है तो they will never mention the sign, because for them it is there, they are not interested in our sign convention, खत्म. लेकिन केमिकल है तो इसलिए, राइट, बिकॉज हमारा रेफरेंस बुक्स मैकेनिकल भी है, राइट? सो सम केमिकल इंजीनियरिंग स्टूडेंट्स मे स्टडी फ्रॉम मैकेनिकल बुक्स ऑल्सो, राइट? सो टू अवॉइड कंफ्यूजन स्पेसिफिकली वो लोग मेंशन किया है वर्क डन बाय द सिस्टम, उन्होंने पॉजिटिव लिया है. सो वी नीड टू टेक दैट ऑल्सो इन टू केयर and then we should solve the question. So Q minus W is path independent, that is the correct answer. Clear? I hope that part is okay, right? So this is next problem. I will read the question, okay? This is not a gate question, this is a textbook question from your Senjal, okay? So you can see this question and you can solve this question, okay? I will read the question, you can see this. A rigid tank, okay? Rigid tank contains a hot fluid, okay? Rigid tank contains a hot fluid that is cooled while being stirred by a paddle wheel, okay? So you can see here, a rigid tank contains a hot fluid that is cooled while being stirred by a paddle wheel, okay? Initially, the internal energy of the fluid is 800 kilojoule, right? Initially, the internal energy of the fluid is 800 kilojoule. Now, during the cooling, fluid loses 500 kilojoule of heat. So there is a heat loss of 500 kilojoule from the fluid, right? Now, and paddle wheel does 100 kilojoule work on the fluid, right? Paddle wheel does 100 kilojoule work on the fluid. Determine the final internal energy of the fluid, right? Determine the final internal energy of the fluid. So those who know how to solve, those who want to try it, right? So just pause the video and try it, right? So and find the answers, right? So I will read the question once again. A rigid tank contains a hot fluid that is cooled while being stirred by a paddle wheel. Initially, right, the internal energy of the fluid is 800 kilojoule, right? During the cooling, fluid loses 500 kilojoule of heat and the paddle wheel does 100 kilojoule work on the fluid, right? Determine the final internal energy of the fluid, right? Determine the final internal energy of the fluid. Clear? So if there are options in the question, right, remember, if there are options in the question, logically what kind of answer it should be, right? Logically what kind of answer it should be. So logic is very much important in all question. Okay, like what is the exact meaning of logic? I will explain. What meaning is very simple. आपको आंसर का रेंज पता होना चाहिए, नहीं तो आपको आंसर का रेंज प्रेडिक्ट करना चाहिए, बिकॉज यू आर राइटिंग ए गेट एग्जाम, राइट, नॉट ए सिंपल टेस्ट सीरीज और नथिंग, यू आर राइटिंग द गेट एग्जाम, राइट. सो उन्होंने जो भी क्वेश्चंस प्रिपेयर कर रहे हैं ना, राइट, whoever is setting the question paper, they will know the logic, right? So they are that kind of people and they will create the question logical only, right? Logical in the sense, आप यहाँ पे देख लीजिए, 800 kilojoule is the initial internal energy of the fluid, right? Initial internal energy of the fluid is 800 and it is a cooling process, right? If it is a cooling process happening, so obviously your final internal energy will be less than this 800, right? Because the fluid is losing heat, right? It is cooling, so the internal energy of the fluid will go down, right? So if there are 4 options and all the options are greater than 800, right, 3 options are greater than 800 and only 1 option is there less than 800, you can directly tick it. Clear? So these things you need to understand, right? So that's what I said regarding the logic, right? Another thing I will say, I hope first sentence is not required, so I will show it here. For example, in a question in heat transfer, I am saying for the logic purpose, okay? In heat transfer, I hope you might have studied this. Water is going through a pipeline, right? Water is going through a pipeline and they will say water is entering at 70 degrees Celsius, right? And it is cooled to some 40 degrees Celsius, right? So this is your question from convection, right? Internal fluid flow, right? Internal convection. This is a question from that, right? And the question will be, here your surface of the pipe is maintained at some 10 degrees Celsius, or I am saying the surface of the pipe is maintained at some 20 degrees Celsius, right? So due to that 20 degrees Celsius, your water is cooled to what? 40, right? Due to that your water is cooled to 40, right? So the question will be what? Simple question. The question will be, what is the length of the pipe, right? What is the length of the pipe? That is, up to what length you should keep the pipe length so that your outlet temperature is 40. मतलब आपके पास एक फ्लूइड है, मतलब इट कैन बी वाटर, वाटर इज एंटरिंग इनटू अ पाइपलाइन एट 70 डिग्री सेल्सियस और आपका जो सरफेस है इट इज मेंटेन्ड एट 20. आपको कितना लेंथ पाइप चाहिए होगा सो दैट योर आउटलेट टेम्परेचर इज 40. दिस इज द क्वेश्चन, राइट? दिस इज द क्वेश्चन नॉर्मली दे आस्क. सो ये सॉल्व करने के लिए आपको क्या चाहिए? व्हाट इज द इक्वेशन? आई होप यू रिमेंबर. इफ यू हैव द इक्वेशन, कांस्टेंट सरफेस टेम्परेचर केस, you have the simple equation, Q is equal to m dot Cp delta T equal to H A delta T Lm. Simple equation, right? For finding H, sometimes they will give the value of H, sometimes otherwise you have to find by using what? Your convection equations. Area, you can write it as pi into D into L. Diameter will be given, length you need to find. That is the question. Now remember, right? Now remember, what is the value of LMTD? Right? It will be 70 minus 20, delta T1 is 50, 40 minus 20, delta T2 is, what will be that? 20. ठीक है? So now you are using LMTD value for finding the answer. Right? You are using LMTD value. You need the LMTD value to find the answer of length. Clear? Because area is pi into D into L. So you need to find the value of what? Area. For finding area, you need LMTD. Now you are using the LMTD calculation. ठीक है? What is the value of LMTD? What is the equation for LMTD? You remember? Delta T Lm is equal to T1, that is delta T1 minus delta T2 divided by ln of delta T1 by delta T2. Now is the problem, because आप लोग जो solve कर रहे हैं ना, you are using the virtual calculator. If you didn't use the virtual calculator properly, your answer may be coming as wrong, right? So आपको ये range पता होना चाहिए. मतलब you are taking an average between 20 and 50. Your answer should come in between what? 20 to 50. Your answer of LMTD should come in between 20 to 50. You should not get 565 as LMTD. You should not get 55 as LMTD. You should not get 15 as LMTD. You should not get 5 as LMTD. You should not get 10 as LMTD. आपका जो भी LMTD का आंसर होना चाहिए, that should come in between 20 and 50. Why? Because you are calculating an average value between 20 and 50. Clear? You are taking an average between 20 and 50. Right? We are using LMTD because it is the most approximate value, most appropriate value. Right? So remember, you need to understand the logic of what is behind this LMTD. You should know your answer should come in between 20 and 50. Then only, right? Then only you can avoid the calculation mistake. As I told just now, 800 kilojoule is the initial internal energy. So your final value should be less than 800 because it is a cooling process. Right? So I hope you understand why I have explained this much logic. Clear? So logic is important. So you should know what is you have to predict the answers. Right? Then only you will be able to understand, okay, there can be a calculation mistake possibly. Right? If there is a possible calculation mistake, you can do it. Right? Why I am explaining so much? Because maybe in the exams you write, maybe in your test series or any other test or textbook question, they may not consider all the actual value. Right? In GATE, if they give you water, right, they will be giving you all the exact properties of water. If they give you an oil, right, it can be any oil, they will be giving you the exact properties of oil. There will not be any change. Right? So you should get all the values approximately correct. Clear? So predict your answers before getting that. Right? So you should know the range. That is, my answer of LMTD should come around 20 and 50. Clear? You should not get below 20. You should not get above 50. I hope you understood what I am trying to say. Clear? So now we will solve this question. Now we will solve this question. What is your equation? We need to find what? Final internal energy. So you know U2 minus U1 is equal to what? Heat transferred between process 1 to 2. Work transferred between process 1 to 2. So always whenever you do problems, right? Whenever you solve problems, write the given value. What are the given value here? U1 is 800 kilojoule. Fluid losses 500 kilojoule of heat. So heat lost is minus 500. Why I am writing minus 500? Because it is heat loss. Whenever there is a heat loss from the system, it is negative. That's why minus 500. Clear? Now, paddle wheel does 100 kilojoule on the system. Work done on the system for us. What is the equation for work done on the system? For us, it is positive. So my answer will be 100 kilojoule. Positive. Clear? No change. Now, can I write it? U2 minus U1. Right? That is, I am writing it. U2 I need to find. U1 is 800 is equal to minus 500 plus 100. So what will be the answer? U2. 800 minus 400, it will be 400 kilojoule. Is it okay? I hope all of you are getting the answer. Clear? 400 kilojoule will be your correct answer. And those who are asking, right, so what will be the answer if you use the other equation? आप लोग यहाँ पे check कर सकते हैं. If you use the other sign convention, your equation will be what? Q12 minus W12, right? W12, work done on the system, for them it is negative, right? Work done on the system is negative for them it will be minus 100. Clear? So is there any change? No. Clear? So it will be what? Substitute the value, you will get the answer. Right? Same thing. Do it. U2 is needed to be calculated. U1 is 800 equal to Q12 is minus 500 minus of minus 100, it is plus 100. You are getting the same answer, right? You are getting the same answer. Clear? I hope you understood. Right? So this is the basis of our calculation, right? This is the basis of our calculation. I hope you are able to understand this. So go through this question again, right? So if you have any confusion, you can ask. Right? I hope all of you are getting this, right? So that is regarding our work. Now tomorrow we will be starting our reversible process in the closed system. That is most important lecture. That is your all problems in gate you can solve based on the tomorrow's lecture, right? Why I'm not starting today? Because I require more than 1 hour for that, right? That's the only reason. So tomorrow we will start fresh, right? That's all. So in next class we will meet. So whatever doubts you have, you can send it in Telegram group as well, right? So remember, solving gate question is more important, right? So the climate here is not good right now. So tomorrow we will continue the next particular session. That's why voice is disturbing, okay? So no problem. Tomorrow, in the tomorrow's video, we will start the new topic, right? That is most important topics will be discussed tomorrow. Thank you very much.